Hello everyone, this is Sriganesh, a faculty from Department of Mechanical Engineering, BMS Institute of Technology. In the last class, we had seen about the classification of turbines and also the working of Pelton turbine. But before we proceed, I'd like to just touch up about the working of Pelton turbine once again and then continue on the working of the Francis turbine. The other end of this Pelton turbine is connected to the other end of this shaft is connected to the generator. So this will start producing power once the shaft starts to rotate the generator also. Right? So because of the nature of the impact force of the water, this type of turbines will fall under the impulse type of turbines. Next is that the water is being made to flow perpendicular to the Pelton cups. So thereby the flow of water in this type of turbine is tangential in nature. Now when we look at these Pelton cups from the right hand side or from the nozzle, the Pelton cups appears to be like this, where it has got two portions, two hemispherical portions, and the water coming out of the nozzle is being made to strike exactly at the center, where this acts as the divider to allow the flow of water to be diversified in both the directions. After impacting onto the turbine or the Pelton cups, the water falls down to the tail rails due to gravity, and there is no draft tube required for this. Right? So this is the working of a Pelton turbine. Now let us go to a Francis turbine. And Francis turbine, the figure shows the drawing of the Francis turbine. What we here see is the front view of the Francis turbine. The Francis turbine is actually used for hydroelectric power plants, which consists of a reservoir water level greater than 30 meters and less than 100 meters in height. So this turbine consists of a spiral casing, a guide blade, moving blade towards the center, moving concentric in nature, and at the center there is a shaft. The turbine has an inlet for water flow connecting from the reservoir through the penstock. The turbine also has a draft tube. Now let us see the working of Francis turbine. Water from the reservoir flows through the penstock and enters the turbine at high pressure. This water is made to flow over these guide blades. The guide blades guide the flow of water towards the moving blades or the turbine blades. So the main purpose of this guide blades is to guide the flow of water from the periphery and push it towards the center and to allow them to flow over the turbine blades. These guide blades can be adjusted for a particular angle, that is plus or minus 15 degrees, so that the flow of water, the angle at which it is going to strike the moving blades, can be adjusted. Next, the water entering at high pressure after moving or flowing over the guide blades is made to flow over these turbine blades at high pressure, and due to this high pressure the blades starts to rotate as the water flows over them, thereby rotating the shaft, and the other end of the shaft is connected to the generator through which power is being produced. Now there is a draft tube present in Francis turbine. Here we can see that a portion of this draft tube is written in dashed line, meaning it is hidden. That is, all these portions looking from here, that is the guide blade, the moving blades, are all to be visible, and a portion of this draft tube is hidden, that is, it is behind the Francis turbine. Note here that the shaft for this turbine is horizontally placed, and at the back side of this turbine we have the draft tube placed. So this draft tube has, at the turbine end there is a narrow region. As it moves below, the area of the draft tube increases. Now the draft tube, the other end of the draft tube is submerged in water in the tail race. That is, we have water up to this region. So there is a low pressure created in the draft tube. But on the other hand, we have water to be flowing at high pressure. So once the water is made to flow over the turbine blades, then it enters the draft tube region and is going to go out of the turbine through the tail race. So there is a pressure difference, that is a high pressure at the inlet and a low pressure at the outlet or the draft tube region. So due to the pressure difference, the turbine is made to run efficiently. Next, the next point that we have to note here is that there is no nozzle present in Francis turbine, but there is a draft tube needed. But in the case of a Pelton turbine, there is a nozzle present and there is no draft tube, right? Because in a Pelton turbine, they work on the impact force or the kinetic energy of water, but in a Francis turbine, they work on the pressure difference. Thereby, Francis turbine will fall under the category of reaction turbines. Right? Yes. The next point that we have to note here is that the draft tube that is present over here. So please remember this, that there is no nozzle present for a Francis turbine, but there is a draft tube that is required in this case. Yes. Next, coming to the flow of water. Now if you look at this movement or flow of water from the entry of the turbine and exit of turbine, the water flows radially inside and exits axially outside. That is, the water exits parallel to the shaft and then enters the draft tube and exits out through the tail race. So thereby, if you look at this, the water enters radially and exits axially. So therefore this type of turbine has a mixed flow in nature. So thereby they fall under the category of mixed flow reaction turbine, right? Yeah, I hope it is clear. Thank you.